Amazing, right? Like, those guys know what they're doing. Visual wolves. We will put it out for you guys to share. But you got a sneak peek at some of the names that we're going to be seeing throughout this whole event. And today, I am honored to be with these fine gentlemen. Before we get going, I want to tell you, so unfortunately and fortunately, Nick Sampson can't be with us. He emailed Thursday saying that they're in the middle of a big fundraising round. And if you know anything, I was really excited to have Faraday Future here, but also at the same moment, they're one of the most high-profiled startups, but also one of the most controversial ones right now because of the funding from China and how they're falling apart, yet they're still trying to build forward. So in place of Nick Sampson, which he said he will come and do a summit, so we'll have one of those for the ICLN coming up sometime this fall probably, so he still wants to come to Coeur d'Alene. We have Mr. Brent Regan, which, if you don't know, Brent and a team of people hold the record for the longest semi-autonomous trip for a vehicle, correct?
That's correct.
So the world record for that. So he will fill you in on some of those pieces. I will introduce them briefly, and then I'm going to turn it over to these fine gentlemen to dive in and talk. But JD Claridge has built a company called xcraft.io. And it's an incredible drone company that not only builds consumer-grade drones, the world's fastest consumer drone, but also now moving into the space of public utility drones and different things for cities. He'll touch on that. You have Brent, who is just a mad scientist. I will leave it with that, and he can talk into all those details. Also broke the record in the Oshkosh race. And then you have Mr. Bert Rattan, who one morning I woke up, and I go to Flipboard, as I do, and I'm going through my morning news on Flipboard, and there's an article about the greatest engineers in history. And I'm flipping through, and it's Galileo and all these people. And then you're on it, and I'm like, what? I was like, hold the phone. I know him, and nah. But if you know Bert, let me tell you this. That list was not wrong. This man is literally one of the greatest engineers in history. He deserves to be on that list. He is the first person that designed a plane that flew around the world without ever stopping. He is the first person to design something that went to space with civilians 2 times in 1 week. He has designed ridiculous amounts of airplanes that have changed how the whole world thinks about aerospace. First to use composites in the space. I mean, a brilliant man. So honored to have these guys discussing what does the future of mobility look like, of moving people and things around the world, because it's rapidly changing right now. So we're gonna have Brent go first, and we'll have JD and Bert, and then we'll do some Q&A from the crowd.
Really?
And please silence your phones.
Good morning. We've got some slides here that we'll pull up in just a second. Thank you all for coming, and thank Nick for putting this together. It's really a remarkable event, and for people to get together for the sole purpose of thinking about innovation and thinking about the future. The guy that was here, or that was supposed to be here, was going to be talking about cars, and that's the Faraday Future Fellow. I own a Tesla, so that's close.
Possibly better.
The joke that's been going around is that if you have a Tesla and it gets stolen, does it turn into an Edison? So, so I'm going to talk about transportation innovation, and I'm actually going to talk about the non-terrestrial type a little bit here, which is 70% of the planet. We know more about the surface of the moon than we know about the bottom of the ocean. And we have this remarkable and tremendous opportunity to research and to explore the oceans. And so we're going to talk a little bit about that. But first, let me talk about innovation itself. Innovation comes from many sources, but 2 really potent ones are imagination and application. And I'm going to talk about the application one, but I'm going to show you an imagination slide. And that's this one. It's one of my favorite slides. Who knows what the thing on the left is? Star Trek communicator, 1963. Beam me up, Scotty, right there. Think of all the kids that saw that, lived with that. And you know what they saw? Because when you're watching science fiction, your ability to suppress what's impossible is huge, right? You know that anything can be done because you don't have to worry about what's possible. And so here you got this little kid in 1963, he's looking at that communicator, says, that's how we're going to communicate in the future. Absolutely. I know this. I've seen the future. It's on Star Trek, right? So all these years later, 40 years later, those same kids have grown up. They've gone to engineering school. They're working at Motorola. And somebody goes, we're going to design this new phone. Who knows what it's going to look like? I do. Right? And there we've got it. So that's how imagination is so important. Application. You're a Silicon Valley billionaire. You live in Hawaii. And you want to listen to whales. Why? Doesn't matter. You're a billionaire. Right? And so you go and you put a hydrophone in the ocean off of your oceanfront property in Hawaii, and you know what you hear? You don't hear whales, you hear those little guys on the right there, the little snapping shrimp. Billions and billions of snapping shrimp. And how is it that this little tiny creature can get in the way of such a giant creature that's 1 billion times its mass? Well, you ever tried to sleep in a room with a mosquito? All right? So, how do you do this? We got to put a hydrophone offshore in Hawaii. Maybe 4 or 5 miles, get away from the noise of the snapping shrimp. Hawaii, though, isn't really an island. I mean, it's a volcano, and it isn't a volcano on the surface of the ocean. It's a volcano on the abyssal plain, which is 18,000 feet down. And the shape of the volcano is volcano-shaped. We all know that from science fair, right? And so, if you go out far enough so you don't hear the snapping shrimp, it's 18,000 feet deep. How do you put something in the ocean at one place and keep it there without running miles and miles of anchor chain? How do you do that? Well, the answer, as it turned out, was this thing. It's called the wave glider. And we're looking at a shot from the bottom going up the top. There's a float about the size of a surfboard, a tether that comes down, and then a submarine with wings. And how it operates is as the wave lifts the float, the tether pulls on the sub, it has a fin on the back, and that fin then tips down and causes forward thrust. And on the back side of the wave, the float comes down, the submarine goes down, the fin goes up. And this up and down motion, it's just like how a whale swims, right? That flip. And that concept arrived at a guy who had gone scuba diving. Graham Hine is his name, inventor of this. And he was scuba diving, and he had a deep dive, and he was decompressing on the anchor line at about 10 feet. And he's out like this, right? And the anchor line's going up and down with the boat. And he realizes that motion you could derive energy from. And he kind of parked that in his brain. So when this application came along, he was able to apply it to this particular and come up with this guy. Now, why does it have so many wings? Well, as it goes up and down, the motion of the wing going from the high state to the low state, that travel is lost, right? So that kind of dictates what the minimum ocean wave state has to be. So the shorter the wing, the lower the ripples can be in order to get the energy out of it. And they arrived at about 5 or 6 wings was the perfect combination between the two. And so here we see it up on the surface, and down at the bottom there you can kind of see in the water the little submarine. That's another shot of it looking from the bottom up to the top. Now, the layout of this is on the float, you've got a computer, satellite comms, like a Iridium modem, battery, solar panels, and then the tether goes down, and at the bottom there's a compass and a rudder that's commanded from the float on the surface. So that whole system is pulled along through the water by the submarine. And the neat thing about it is, if you tell it to go to a certain, it has a GPS, so if you tell it to go to a certain GPS coordinates, it'll go to those coordinates, and it'll actually motor right through them. And after it goes through them, it says, wait a minute, they're back there, and it'll turn around and come back. And then it'll turn around and come back again. And it'll sit there within about a 20-meter watch circle forever. Forever. Now you can make all kinds of measurements, you can monitor the weather, you can listen for bad guys. There's ones off of Fukushima that are monitoring radiation from the reactors. There are ones in the Gulf Coast monitoring oil spill. They're all over the place now. I went to their facility a few years back, and there are all these black ones. They're flat black. I said, who are those for? Can't tell you. And this is the best part. They launched 4 of these from the San Francisco Yacht Harbor and drove them to Australia. And that's how much fuel they used. They harvested all their energy from the wave energy, which is wind energy, if you will, wave energy from the ocean, and solar energy to power the computers from the sun. So the duration of this thing is basically infinite. What happens is barnacles and that accumulate on it, and the performance keeps going down after that. So a year to 2 years is about the limit of what you can do right now with the biofouling materials that are available. But that's remarkable. What's the future like? How about zero energy consumption? And to be able to go anywhere on the planet where there's water. Got a few awards. And those awards are nice. But the technology is the cool part, right? The ability to do that. And think about all the possible things you can do for it. How about taking one of these and putting a magnetometer out the back of it and just going back and forth and back and forth and back and forth and get a really detailed magnetic map of the ocean, which will tell you where all the Spanish treasure is. Imagine what that data is like. The best way to predict the future is to build it. We're talking about the future of mobility. Let's build it. Thank you.
Morning. I'm JD Claridge, CEO of Xcraft and founder. Xcraft is a drone company. We develop powerful flying machines that change the world. That's our mission. So a pretty big mission. But we've done some pretty interesting things. Started out with, to start the company off, we ran a Kickstarter campaign. If you guys have heard of Kickstarter, way to crowdfund and get your idea out there and bring in a little bit of money. And we were able to successfully do that with our first product, the X+1, which is a vertical takeoff and landing drone, and then high speed. So it takes off and lands vertically, but then travels long distances efficiently. And we see that as definitely the kind of vehicle, kind of platform that drones will be, that type of use case is going to be needed in the future in a lot of different verticals. So, give you a little bit of background about my story. A lot of people ask me, why are you into drones, or what got you into drones? And I usually say, I didn't have a choice. For me, I've always had a passion for flying things. And even when I was a young kid, I remember building all sorts of little inventions that flew. Did build a hang glider when I was 7, I think, and out of parts I found in the barn, like rebar and other things, duct tape, and then put a sheet on it from my mom's closet. And I wasn't quite ready to fly it, so I had my best friend fly it. And it flew about as well as you would think a rebar hang glider would fly. But learned a lot about that, and all through growing, a lot of learning experiences, a lot what people would probably call failures, but I call opportunities to learn. So in talking about what the future is, this is the Think Big Festival, and talking about the future of mobility and where we're headed. I wanted to share a little bit about where we're headed in the future as far as drones and commuting, transportation, and how those might be related. So I have a rendering here of something we're working on. This is top secret, so don't share this. But it's kind of the future of commuting as we know it. So, there you go. Not really. It's not quite that, but we do see a future where drones, and specifically autonomous vehicles, are used more in everyday life. Really, the technology has the power to disrupt transportation as we know it. And so, likely, there are a few companies, Google and others, that are working on projects for autonomous vehicles that will carry people. And a lot of those companies are working on relatively large vehicles that carry multiple people, can travel long distances, and at high speeds. And I don't think that's where it's going to start. I think there's going to be, at least from the technology that's already there, I think we're going to see something more like this in the way that, in how the technology builds. Small, probably single person carrying initially. Would you guys fly that? Yeah. I'd fly it. That's not me. But
It's your friend who did the glider in the bar.
right. So there's, I think, initially anyway, we're going to see practical applications of autonomous vehicles being smaller, have more limited range, say 20, 30 miles, not high speed necessarily, maybe 60 miles an hour, something like that. Because honestly, most people, and if you look at this, the HOV lane on the highway is not that crowded. Most people travel one person at a time. And so there's need for a vehicle that can get from point A to point B, miss all the traffic, all the terrain, everything underneath it, and go directly to point B without the need for at least minimal traveling on roadways. So it's pretty interesting. There's a company right now in Dubai that has this vehicle that they're testing.
One of my slides.
This is one of your slides? Cool.
You weren't supposed to hear that.
Well, I won't steal your thunder. But this is pretty interesting. They're looking at an air taxi, and I don't. Bert probably knows more about it as far as where they're at, but they are. This is a flying vehicle, and the regulations are such in the U.S. that it's difficult to test an application like this. But in Dubai, they apparently don't have those regulations. So this is already happening, and I think in the very near future, we're going to start seeing real applications of people being moved by autonomous vehicles where no one inside the vehicle is controlling it necessarily. The people inside are just saying where they want to go, and the vehicle takes them there. So that's really what I see for the future, and we have some long-term, at Xcraft, we have some long-term visions of vehicles like this as part of what we do, but I appreciate you listening, and thanks for having me.
Morning. I'm on the schedule to talk about mobility in the future for space. And I got to thinking about that. I don't have really good news on that, so I've tacked on a couple of slides on the end to talk about mobility for urban travel and to talk about mobility as far as domestic airline travel. So I'm sorry for missing the agenda, but the car guy didn't show up, so that's my...
Just because you got on the list of 10 engineers, we just kind of give you a pass to talk about whatever.
Okay. First of all, America did phenomenal progress when it was driven by politics. Now, politics meant the Russians really made us look bad, and we're thinking, God, they're third world, and they had Sputnik up before we had a satellite, and then when they launched Gagarin, oh man, we really lost. Actually, we would have won the first man in space if we had flown one less monkey. Really, and I'm glad we didn't. I'm glad we flew that monkey, because it was very embarrassing to America. How many of you remember that 1961 when Gagarin flew and we thought, oh crap, we were working on. But anyway, that was a big hit to national prestige, and it was a recovery of our national prestige that caused some phenomenal things to happen. And I'm going to talk about the 60s a lot more. However, in the decade of the 70s, we didn't develop an efficient manned orbital access. We abandoned this wonderful thing that we had is, hey, let's go to the moon and back, and that worked. We didn't kill anybody doing that. and yet we abandoned it. We stopped flying all 7 of the human launch systems that we flew in the 60s. What? Now think about that. In the 60s, which included 1961 with Alan Shepard flying in the Redstone to space, America developed 7 different launch systems, flew them all successfully. And in the 70s, we stopped flying every one of them. Can you imagine that? Like somebody invented the car, and we had all kinds of cars developed in one decade, and the next decade let's not drive anymore. That's what happened to space. Weird. Well, here they are. These are 9 things. Russians did 2. These are 9 rocket systems developed to put people in space. They were all done in the 1960s. Those of you that were around in the 60s watching this happen, we almost thought it was normal because every year there'd be a new one. Now, most of these were war boosters, like the Sputnik was an ICBM, and the Titan, Gemini, the Titan was intended to put nukes on Moscow. But actually 4 of these in the 60s were all new research rockets, all developed and flown safely in the 60s. Well, the next 35 years, 69 all the way up to 2004, there were only 3 new manned space launch systems that put humans in space. Of course, the biggie that America did was the space shuttle, which was actually launching a space station and then deorbiting it every 2 weeks, So, and then, of course, the Chinese Soyuz, or Shenzhou, and a little team of guys working for me in a company that had 120 employees, and we did this with about 3 or 4 dozen people. We had a covert program for 2 years, and then we told everybody what we were doing. And in 2004, we flew 3 of the 5 manned space flights in the world with our little Spaceship One. So that there's only 3. Well, what happened after 2004? This last 13 years. Everybody seems to think that, my God, look at all the neat things going on with Musk and Bezos, and entrepreneurs are doing this now. And, I got up after the first space flight that we did in 2004, and I said, within 10 years, you'll be able to be buying tickets, there'll be competing space lines, and thousands of people will go to space instead of just 462. And would you have believed, I didn't, that the last 13 years, 0. There have been no new rocket systems that flew humans to space. And the only thing that's flying humans to space during this time period is a defunct shuttle because it was too expensive and too dangerous to fly. Shuttle ended up to be the most dangerous way to launch humans in space, statistically. And the Russians are the only ones doing it, and they do it with a rocket that was on that other list, the Soyuz. It's 50 years old. That rocket system is 50 years old. And it was done just 6 years after the first man in space. And that's all that's flying now. What? That's so nonsensical. Well, what's new? Also, there is nothing even being developed right now that can do the moon missions. You've heard about every new president says, here's my plan for space. We're going to go to Mars by next 30 years. We're going to do all of this. There is nothing being developed anywhere in the world that can fly the Apollo 11 mission. Now, isn't that weird? People think, hey, there's a lot going on. Well, the only thing that's going on is to put people to where John Glenn went in the Atlas, low Earth orbit. Okay, now the good news, though, there is something new, and the most important development, I believe, for future human space flights is what Musk and Bezos is doing right now, and that is to reuse the boosters. Fly them back, land them, turn them around, and that's the only thing that's genuinely new that has an enormous amount of progress. I don't believe that NASA or the Russians would have ever tried to do that. It had to be entrepreneurs in the mindset of an entrepreneur that went after that, because the entrepreneur, he thinks about market share. And he thinks about, hey, if I can reuse boosters, I'll get all the market. Government doesn't think like that. Okay, I want you to look at 3 programs, the Saturn V booster development. By the way, the Saturn series, the Saturn I, Saturn 1B, and Saturn V never had a launch failure. Every time they pushed the button, the mission was done. Wow, 100% reliability on a brand new rocket. First time you put humans in a Saturn V, it went to the friggin' moon and orbited it. Let me say that again. First time you put humans in it, we'd only been like 300 miles off the Earth, and we went to the friggin' moon. That was cool. The Apollo moon program and the Skylab space station, which has a much bigger room to tumble around in than anything that the International Space Station has. It's a bunch of boring science labs. Compare those 3 programs with anything going on now. All 3 of these were done quick and without mission failures. Everything done after that were slow and had major failures. Okay, here's the reason that I thought I would go to space in my lifetime. By the way, I no longer think I'm going to go to space in my lifetime. I'm 74 now, right? Alan Shepard, I watched him as I was driving to my college to check it out, or I heard him on the radio. Less than 10 years later, that same guy that flew this little suborbital flight, he had a 6-iron hitting golf balls on the moon. Now, what have we done in the last 10 years? Right?
No.
Just think about that. 10 years later, he's playing golf on the moon? Do we have anything at all to brag about now for human space travel? Hell no. And I think a lot of it has to do with we're not making decisions for national prestige. We're not making decisions because we think it's important to make America great again. We don't have that mindset that's driving us at all. And I think that's an enormous failure. Okay, how many people here were born before 1935? Okay, I want somebody in the audience to lie and raise your hand and say you were born, yeah, you were born. You know, you are very special. You know why? You are in a group of people that have walked on the moon. All the rest of you are not in that group. Aren't you embarrassed? Okay, I say it takes a village. This is the size of my company when we did Spaceship One. They're around the V-Jet. The size of my company when we did Spaceship Two for Richard Branson. And my company is about 800 people now while we're building something for space. And it's the Stratolaunch. Here's kind of a cool period. The first, or a picture. That T-hangar, by the way, has the widest door in the world. So it can get an airplane outside that has a wingspan of 385 feet, by far the largest airplane in the world, and the picture was taken while Spaceship Two was landing. Okay, what is it? Stratolaunch. This little thing at the bottom here is a comparison between a lot of scale composites products that we did for research. And the one on the lower right there is White Knight 2. That has the same wingspan as the biggest bomber in World War II, the B-29.
Wow.
Okay? And we're friggin' building that big one. There it is. We parted out two 747s to get their engines and landing gear.
Wow.
Okay, America has only two sites for orbital launch, Cape Canaveral and Vandenberg. Both of those are military sites, and you don't fly your commercial stuff if the military wants to fly a spy satellite. You just, you can't even go near it. A lot of times Cape Canaveral looks like this, and you don't fly then. There is no way to have a growth of volume of flying everybody to space like we want to do by using these two military sites and using a place that has that kind of weather. The beautiful thing about Stratolaunch is everything is blue in this picture is a place to launch. And that's the most important thing about Stratolaunch. Okay, I made this up just before we did the first commercial space flight in 2004, and I presented it to Paul Allen and Richard Branson in my living room to kind of impress them about what I think could happen in my lifetime. I didn't change the dates on this to kind of make a point. I predicted that this would enter service in 20 years, which is only 6 years from now. I predicted that it would be affordable in 30 years, and thousands of people would fly to orbit and have their vacations in either the 0.1 G thing that spins or the 0 G thing that you can play other games in. And I predicted that in 15 years, every child will know that if he wants to, where's that young child? Yeah, if you want to, you can go to orbit in your lifetime. You will know that. Okay, anyway, I've been very bad at predicting. Okay, I'm going to talk about real quickly, I don't have much time, mobility issues. One is domestic travel. You know, we drive cars, we take Greyhound buses, and we take airliners, commuter airliners and so on. Well, in 1997, I was extremely excited about having the New York taxi cab system, but have it for all of America. That was long before Uber. I'm talking about 97 now. And where you'd take your phone and you'd call up, and now you can go somewhere. So we developed an airplane for Dr. Williams International called the V-Jet. The airlines fly to 376 airports. This flies to 12,000 airports.
Wow.
And if you look at the average times, not from takeoff to landing of an airliner, which is a tiny portion of your door-to-door time, door-to-door, average times, travel in United States, this is 38% of the time of the airlines. It's more than twice the speed door-to-door, and it's the only thing that will work, and nobody's working on it. Now, the reason they're not working on it, New York City, Manhattan Island, has, I think, 7,000 cabs, okay? And boy, it works really cool. Everybody uses a cab. What if they had only 1,000 cabs? People would use a subway because the cabs, you can't get one. To have this successful and have it actually work, you have to start with 20,000 airplanes. So I was really optimistic that this was going to happen because, oh my God, we can cut down to 38% of the time for all domestic travel in the US. Wow, it's got to happen, right? I'm not optimistic now because somebody has got to find the bucks and put this all together so that the cabs actually can work. Okay, urban human mobility. This is when I was chuckling because I used one of your slides. And last year at this, I didn't think they'd invite me back because I trashed one of the guys on the panel.
You can always come back.
I told him that there was a system in Douglas that well, I don't have time to tell.
Well,
that story.
basically, I'll tell.
Probably
a story.
all of you guys were
no,
here
I'll,
then.
I'll
but-
tell the story. Last year, we had Starship Technologies here, founders of Skype. They've done nothing significant.
Had a beer cooler that could take one thing.
And then they invented like these robots, which have done like 5,000 deliveries now in cities, and it's kind of nifty. It's cool, and they're trying to reduce traffic and hot time for like delivery to front doors. And they have one rolling around the stage. You know, they came here. They didn't come back this year, Bert, if you noticed. And so they're at another conference in Boston. And they're like, is Bert coming? I was like, yeah. And then they booked the Boston one. And so then this little guy's rolling around the stage. And sure enough, Bert's like, that's nifty. We had girls in short shorts and roller skates in the 60s that did the same thing.
Douglas Aircraft, hey, this was, you know how skirts went way up and then now they're going to sag way down again?
Stop the story,
when the
Bert.
skirts were the height.
You have slides to talk about.
Okay, can I say during the miniskirt era, there
sure.
were girls on roller skates delivering documents inside Douglas Aircraft.
Yeah.
And they would go down the hallways at many times the speed of that, and they could sort out.
They made a robot version. It's called the
we
rattan.
don't have time.
Hey,
Let's
they have
go.
the
First
rattan.
of
It's got
all,
a skirt
okay,
on the robot.
I'll get in trouble if I talk about. I can't even see men anymore. I had to change all my slides and say human. And I think I took
I
the
love
word.
you, Bert.
No, I won't go into that. I'll get into
Back to
later.
mobility.
Okay, what I'm going to tell you is all of these are wrong. Why are they wrong? They're real inefficient. They use a lot of gas to go a little bit. They make objectionable noise. And they make downwash. And there is no way you could have high volume of stuff within a big city because you can't fly under each other. And you spend a lot of time hovering rather than going somewhere. And everybody seems to be doing this, but all of them are wrong. It's a much, much better way of doing this, and I presented it at a off-site conference for Ford Motor Company, which was in Switzerland. And for some reason, they thought by going to Switzerland, they could be innovative. And I said, no, you should use airplanes, not things that hover. A little airplane with a 30-knot stall speed uses a tenth of the gas that one of these would to go from Central Park down to Wall Street and whatever. Okay? When you land on an aircraft carrier, that's kind of fun. How many have done that? You know, you go zoop and you're stopped. And it's fun, right? And then to take off, you go zoop for like a second and a half at the most. Now you're flying. Okay? So I think these urban mobility things ought to be. Oh, by the way, I'm not going to show you graphics on it because it's so cool that it's secret still. But what it is, the whole building turns. You have one story if you're out in a little community, okay? And for takeoff, you have a 2-second poof that's heard. Now, I was at the edge of this, at the supersonic corridor at Edwards. It's where I did my first 7 years. And we stopped hearing sonic booms. That's weird. We'd have a visitor come in, and we'd see him jump, and we'd realize, oh, he jumped because there was a sonic boom. But short duration, loud noises, you tend to get used to, and then you tune them out. But if you've got something coming in hovering, and now there's 2 of them, and now there's 4 of them, the whole world is horrible. You can't do this. It's stupid. But when you launch one of those, you have a poof, pneumatic launch from the building, and when you approach and land, you come down with no power, using drag to change your speed and your attitude, and you fly right into the building, and you can decelerate in 100 feet and you could take the energy of that deceleration and use it to launch the next one. Now, if you're in Manhattan, this is a skyscraper because you're coming in at different levels, right? And so you stack these things. They're quiet, they're fast, you capture the energy, and that's all I'm going to tell you about. Thank you very much. Yeah.
You're awesome. Hey, we've got a few minutes for questions, but one thing I wanted to say first.
Excuse me, I got to say one more thing. my punchline on that. Sorry about that.
Hey, it's okay.
My punchline, by the way, I used to show graphics of this, and it's really cool. But then 9/11 came along, and Burt Rutan is given this thing with airplanes flying into skyscrapers. So I stopped doing that.
That's probably a bad idea. I will say, it is interesting because even that little bit right there, I don't know if you were like me, but as Burt was describing, I'm like, all right, hold on, what is this? What does it look like? How can this be made? Why is he not showing it to me? Can I do it? Is it possible? Can I be on a part of a team that does it? And that's part of thinking big, right? The purpose of this is to unlock our minds and kind of explore where this could go. So if anything I picked up on mobility from the three of you is that we are not done. And there's plenty of room to innovate. We have time for probably, let's take 2 questions, and then we're going to bring out the Future of Humanity group. Yes, in the back. And say your name, too. So what do you see in saturation of airspace and how to control basically all the airspace? Is this directed directly at Burt or just panel? Absolutely.
Are you talking about urban or, say, CONUS US or? Okay. Yeah. Now, we don't think a lot about that for international travel when you're flying from Los Angeles to Sydney, yep, because all you're going to see occasionally, you'll see a contrail or two, okay? Well, I had the experience of 42 times because of a big air show that happens in Wisconsin that I flew from California in a little airplane all the way to Wisconsin, and that was saturated because something like 7% of the U.S. airplanes go to that one airport during that week, okay? And there's a lot of saturation right there.
Wow.
But you fly the whole way and you don't see another airplane. You might see one, okay? It's a lot bigger sky out there than you think. People say that you can't have more air travel because they'll run into each other. Well, for a long time, the Brits and us used big sky, and there was statistically, it was safe enough, but statistically the sky is so big and the airplanes are so small, and the chance of running into each other is an acceptable risk. Yeah. Now, after the 2 airliners crashed because they came down to low altitude to show everybody the Grand Canyon, in 50s, I guess, and they ran into each other, and now you got all these dead bodies, and you got 2 airliners that ran into each other. After that, we had positive flight control, okay? And that's when all this thing, now we have separation. Now, you remember positive flight control, a little airplane hit an airliner in San Diego, went down. It also happened in Los Angeles Basin. And it still happens when you got positive control. Somebody did a calculation which really fascinated me. After decades of positive control, they did a statistical analysis with real data that shows how many airplanes actually hit each other, and it was exactly the same as not having any positive control at all.
Interesting.
Isn't that weird?
Yeah.
A short answer to your question. There's a tremendous amount of growth, many orders of magnitude before that's a problem.
Okay. There are already systems in place now that have two-way reporting of aircraft position. So that infrastructure is just now beginning, but there's going to be the ability to keep separation from aircraft on a two-way basis.
I think what you'll see in the next decade or so, because now data is all available, ADS-B and so on, I think you're going to see airplanes a decade or two from now that will take over and dodge the other airplane while you're sleeping or whatever and while you're flying. So that problem is easily solvable, but it's really not a problem yet.
But I'm intrigued too to see what happens with domestic flights, right? If we can figure out Hyperloop, if that does come into play, like you know how they're shooting the Hyperloop. Have you saw that at all?
The what?
Yeah. Musk.
Hyperloop. Yeah, it's an interesting concept. And even today, Musk came out and said, "Nifty that there's 3 other companies trying to do my idea, but I'm doing one too." So I don't know if people knew that. That was just this morning. Hyperloop. I talked to them. The CMO, when I found out Nick was bailing, I pinged him real quick. He is willing to come and do something at some point. But look into Hyperloop. It's another fun one where they're shooting people basically on rail guns in little pods from distances like Spokane to Seattle and Seattle to Portland. And it'll be interesting to see what happens with air and ground at rapid speeds or underground.
When Musk announced his Hyperloop thing
Yeah.
and his plans to do it, he's got a car company, builds some kind of cars up in the San Francisco
something.
Bay Area, and he
They're out
lives
front.
down in L.A., so he designed this whole thing for himself.
Yeah.
It goes only from Los Angeles to San Francisco. And the thing I said, who in the hell would want to go to San Francisco from Los Angeles?
You lived in Mojave for a long time. Shut it.
Why would you want to do that? You can do that on the internet.
Yeah. Bert, you're going to hang around for a while throughout things, correct?
Yeah.
You'll be here the day?
Yeah.
Yeah, so Bert will be around. So just grab him by those beautiful mutton chops and just ask questions if you want them. But don't do
They're
that,
in the
actually.
shape of Idaho.
They are. They are. When he was talking about having pride of your country, that's
That's not
exactly
my
what
idea.
he meant.
That's from a biographer.
Yeah, I'll take this question here and then just come and compliment his sideburns and then ask other questions. Yeah.
Kind of the same question to JD about inside city space and neighborhoods versus large cities. We were talking about underground paths for all sorts of different utility companies, deliveries. How do you see that working not domestic space, but
Sure.
Just to repeat the
Yeah.
question really fast, the question was drones in city space, like urban areas. How do you see that playing out with so many people trying to capture that space?
Sure. Well, I may differ a little bit with Bert on that. I do think that there is, even in an urban environment, you think about how many cars are traveling right now inside an urban environment, and that's all in one dimension. You now break open the envelope to up to, say, maybe 2,000 feet or something. There's a lot of airspace. And if managed properly as far as airways, you can definitely manage that for a lot of travel, even a lot more travel than is currently happening with vehicles on the streets.
Give these fine gentlemen a hand. Thank you, guys.
Thank you.
Thank you.
Okay, I enjoyed it.
That was awesome. Thank you. Go ahead.